Hi, hello everyone. My name is Brijesh. I had opportunity to work with multiple telecom operators, vendors worldwide, and worked on 2G, 3G, 4G, and 5G. I'll just walk you through the evolution from first cellular network to till 5G. It is important for us to understand what are the services being offered by these generations of the network and how it has been evolved on different dimensions. So here I'll walk you through the mobile industry journey from 1G, the first cellular network, until 5G, and then I'll walk you through the 5G core architecture. So there are mainly two notation for the 5G core. One is SPI based and other is 5G core reference based architecture. I'll just brief you about that. What is the difference between these two? So if you see, the wireless journey started from first generation in 1980, and every 10 years we have new generation of telecom network. All started with voice, and then Qualcomm and 3GPP. There were two kind of development bodies were formed. As Qualcomm was developing CDMA technology, and GSM was developed by 3GPP. So there were two parallel developments were ongoing till 3G. If you see, after 3G, the 4G where the all IP based communication started, and then Qualcomm also started supporting 3GPP. So after that, you will see the Qualcomm is a partner with 3GPP. It's not carrying forward their own proprietary uh, technology, which was till 3G. So they were granting license. So every network operator has to buy the license from Qualcomm, the chip, and from the telecom equipments as well. So it was a costly affair, and it was like in this competitive market, it was not a kind of a business case to go alone with CDMA. And on the platform level till 3G, it was all proprietary hardware, and then ATKA based hardware was introduced in 2000 near about, and then so there were till then also the hardware on the same hardware, the application vendor, for example, Huawei is deploying their ATKA hardware. They would be deploying their packet core or the CS core component. But let's say Nokia wants to deploy, it was practically not possible. And in generation 4, in LTE, uh, the evolution happened on the hardware as well. So the operators and vendor, everybody started supporting the virtualized application, and there were COT speeds hardware were being deployed, and there were two main player in virtualization and in cloud, if you can say, that is VMware or OpenStack. In 5G, we have evolved like a general software deployment towards the containerization and the orchestration platform like Kubernetes, and the our telecom application will be stateless network functions. It means that if there is a any there is no downtime theoretically. In 5G, we are trying to solve along with the connectivity, we are trying to solve the other industrial problems, and like massive machine type communication, ultra level low latency use cases. These are the broader categories of the use cases, and then there are some subcategories which we'll discuss in separate a video. So if you see the voice, SMS, multimedia, the gaming, all those things are still carrying. And if you see the 2G, 3G, 4G, and 5G network still exist worldwide. So in some of the cases, you will see 2G, 3G, and 4G, and 5G is getting introduced. In some cases, the green operators, greenfield operators, are coming with their 5G network directly, and they will do the handovers to their let's say roaming partner. So compatibility between 4G and 5G is there. So you can do the handover from 4G to 5G and likewise. So it is important for us, if you are there in the industry and want to walk, or you are a new entrant, it is important for us to understand all three or four technologies together. We should have a basic idea of what is 2G, 3G, and 4G along with 5G, because there still interworking is required. So let me just walk you through the 5G core architecture. But before that, I would like to share the deployment options which we have in enable 5G in your networks. So there are 7 options available to implement 5G. But out of those, only 2 options are popular. One is mostly opted by the brownfield operators, which are existing operators. That is NSA, not standalone, not non-standalone deployment. And other is the greenfield operators, which are new operators coming, and they want to opt for the option 2 because it is a new technology, and then most of the new deployments are happening on as a combo core, because still you need the compatibility with 4G, because it is a initial phase of the deployment. So most of the new operators going with option 2, whereas the remaining the old ones are with going with the NSA, which is option 3x. And as the use cases evolve, they will migrate slowly and gradually towards the 5G-C, which is decomposed 5G core architecture. So in core, we have the service-based architecture. Earlier, we used to have point-to-point connectivity between the network functions, network elements. Now you don't have such binding. You have one common interface towards all the network function. So every network function, if you see, can talk with each other. Practically, it is not required, but as per this architecture, every network function can talk with other network function. In the next video, I'll walk you through the key concepts. So one could be a consumer, other could be a producer, and similar vice versa also is possible. So like you can see AUSF is connected on an AUSF. So any message coming to an AUSF will come with an AUSF, for example, authentication. So NUSF underscore authentication will be the message, and then there will be a services for authentication. So these all services will be offered by this network function. So F is stand for function here, and N is mostly network. So any network function start with N is network, and then for example NRF is network repository function, PCF is policy control function. Likewise, I just wanted to walk you through the service-based architecture. Was it the difference? Still, there are four network interfaces which are still point-to-point connected. So, for example, N2 is between AMF and RAN. It is NGAP interface. It is on SCTP, and other is N4, which is on PFCP. So these two interfaces, if you see, these are the one which are still on the point to point. Rest all are SBI interfaces, means HTTP connectivity. Next is reference based architecture. So reference means when you say, for example, N2, it means it is between RAN and AMF. Likewise, the on the SPI layer, also in the control function layer, also you have the point to point connectivity, which is, for example, AMF will talk to ASF on N12. When someone says N12, it means it is AMF to AUSF, or N13 means AUSF to UDM. So likewise, you have the reference name for every interface between these network functions. So that's why it is called reference based architecture. And so practically these are the network functions which is required to offer EMBB or FWA services. And there is another network function called CHF, which is required for charging, online and offline charging. And then you have interface towards CHF is called N40. So that's all we have in this video, and we'll see. Thanks for your time. See you in the next video.